Hi, hello, welcome back to the series in which I code some shaders using Raylib library. So in the previous part I showed you how to install Raylib, and I mentioned I will show you the documentation. I actually forgot to do that. So if you go to the Raylib website and scroll down, you will find the link called check cheat sheet, and if you go there you will find all of the functions Raylib allows you to use, and they are mostly self-explanatory. You can know what they do by name, but there is always some short description of what they do. It seems like this documentation is lacking, but believe me, it's plenty enough for a library like Raylib. You will probably catch up pretty fast with it, so don't worry about that, and you can always look into the examples. Okay, so today I would like to set up the environment for our project. So I created a Raylib shaders folder, and in it I will create source folder. Also I'm using Sublime text editor, and in Sublime you can open this sidebar. I think you do it in view, sidebar, yeah, that's it. Hide sidebar, sidebar, show sidebar, yeah. So if you also use Sublime, you can just grab the project folder and drop it in. And yeah, so let's start by making our main file. So I will just drop in the typical main function. Yeah, something like that, and return 0, and it's like that's the basic minimum. So I will use CPP extension. I usually do that because sometimes when I write programs in C, I want to have some C++ conveniences, so I allow it for myself to do that in the future. So yeah, that's why I use CPP. But in this project I probably won't be using anything more than C, because I will focus mostly on the shaders, so there won't be that much of Raylib programming. Okay, so save it as main CPP. As you can see here, it's saved in a source file. And another thing, we need a basic scons makefile, because as I said before, we'll be using this tool to build the program. It's called scons, and it's like a make, but makefiles are written in Python. That's basically it, and I find it very convenient. Okay, so basically it uses this idea of environments. So you have to define an environment, and later I will fill it in with more data, but for now we just want to compile this simple main.cpp file. So first of all, we need to create an object file from this main source file, and to do that we specify the source, and target. The target will be created main.o in obj folder. As you can see, we actually didn't make a folder obj, but scons will make it for us if it's not there. And from this file we want to make the executable program. For that we use program function, and once again we use target build.main and source. Since the program can be built from many object files, it's a list, so that's why the square brackets. And here we specify the object files. Okay, so now we've got to go to the project folder, Raylib shaders, and here save as sconstruct without any extensions, and that should be it. So now if I go to command, go to the project folder and run scons, yeah, it should build the main executable. So as you can see, it created obj folder, main O, build folder with a main application. If I run it, it does nothing because it's only a main function. And also here in the command line you can see scons actually shows what it does. So first it's used CL program, which is actually Microsoft compiler, and to create the object file, and then Microsoft's linker to link it with everything it needs to be able to run. So as I said before, we won't be using this compiler, we will be using min.gw. And to do that, first of all, we need to specify it in our environment. So we do it using tools, parameter. Yeah, we do something like that, and that should be enough. Now basically when I run scons, yeah, you can see that it now uses G++ for making the object file and for linking. So that works well. Okay, now we can start using Raylib in our project. But in order to do that, we'll have to copy the Raylib library into our project. So go to your Raylib installation. There you will find release folder. Just go in, select everything, copy it, go to your projects folder and create new folder libs. Here in libs folder, just create another one called Raylib, and inside paste in everything from release folder of Raylib. As I showed you before, it has include folder with the header files and libs folder with compiled libraries. So now in order to use it, first of all, just include it in our main program, and let's try to compile. It won't compile, of course, because it can't find raylib.h, even though we copied it into our folder structure, libs raylib include, that's raylib.h. It doesn't know where it is, so let's tell scons by using cpp path parameter that the raylib.h is here. And now let's run scons, and it compiles fine. It compiles fine, but as soon as I use some functions from Raylib, let's say that's the first function we will use, it actually starts the window, it initializes it, so it needs its width and height. So for now let's make it 600 pixels by 600 pixels and call it Raylib shaders fun. Yeah, that will be enough. And now if we try to compile it, it will tell us that there is undefined reference to the function we used. So it sees its declaration in raylib.h, but it can't find its definition. So in order to fix that, we just need to add something to our makefile. First of all, let's add lib path, and in here we will specify where the compiled paths libraries can be found. So libs raylib libs win32 min.gw32. So libs raylib libs win32 min.gw. Am I right? except I forgot 32. Yeah, 32. Also don't forget about the comma between those. So that's the lib path, but we also have to tell it explicitly to add those paths, those libs. Come on. Okay, so first of all Raylib. That's, yeah, lib Raylib, depending if you link to it statically or dynamically, but still lib Raylib. You usually don't need to add this lib prefix. Okay, and also actually you need to add glfw3 and gdi32. So this one you can also find in this folder as this one, but gdi32, that's a library provided by Microsoft. You can read about it on MSDN website. Here it is, and the Microsoft Windows Graphics Device Interface. That's what it's used for. It actually doesn't specify that it's about this. There's no like GDI32 name here on this website, but you probably can find it elsewhere. GDI32 exports graphic device interface functions that perform primitive drawing functions, blah blah blah. Yeah, that's actually what Raylib uses, because we don't actually explicitly state it here in our source file. That's something that Raylib uses, and that's why it needs to be linked to. Okay, so now when we run scons, it compiles, it uses this path we used, and it adds those 3 libraries. Okay, but still, even if we now run our program, first of all, it probably won't run exactly, because it can't link to libraries provided by the compiler, standard C and C++ libraries. That might be something that's wrong with my setup explicitly, and you might not have this error, because those are the libraries the program links into during runtime when it started. So when your paths are set up properly, it should actually work, but for me at this moment it doesn't. So in case you have the same problem, you can fix it by doing something like that with your makefile, using static libgcc flag and static libstd c++. Yeah, that tells the compiler to the linker to statically attach those libraries to your program, and that should solve the problem. Yeah, it compiles fine, and now if we run it, it doesn't throw out error. It closes immediately, but there is no error. So let's use some Raylib finally. Okay, so we initialize the window. Let's now set the FPS target that will limit our FPS to 60, and let's create the main loop of the application. So while window should close, window shouldn't close. Yeah, that's why the exclamation mark. Begin drawing and drawing. Well, let's have him something to do in the while loop. It will just start drawing and drawing. We won't draw anything for now. And we've got to close the window properly. Yeah, and that's the minimal setup to create a window in Raylib. So now let's compile it. Let's run it from here. So main.exe. Oh, okay. Wrong slash. It should be, which slash it should be? It should be this one, yeah. Okay, it opens the window. It uses our title, and it basically does nothing. It gives you a lot of additional information, which is actually useful, especially for shaders, because you don't get actually debugging shaders isn't that easy, and it will tell you here in this terminal window that there's problem with a shader if there is any errors in it. Okay, so now if the window is active, you can press escape. No, you can't. Oh, okay. Oh yeah, because we're not handling it yet, I guess. Yeah, probably. Okay, so just activate the command window, just press Ctrl C, and it will interrupt the process. Okay, we need to, before we end up this part, we'll just fix some things in this source file just to make it more elegant. So let's create some variables for the window width and height. Yeah, that's how it's spelled, right? Yeah, I think so. I hope so. Okay, so change this one to window width and window height. I'm actually not sure if it's width first and height second. So let's head over to the documentation. Init window width, height. Yeah, I was right. Okay, good. Okay, so we've got that out of the way. Okay, so I actually want to be able to control when the window closes a bit more elegantly. So I will create a bool variable which says if program runs or not, and I will use it in this loop. And we also have to check if it's to specify when it becomes false. So window should close and running equals false. Yeah, and that should do it for now. Let's try. Oh no, I started it. Okay, now escaped worked. Okay, it compiled, and of course not the proper slash, this one. Okay, yeah. So now we've got window that does nothing, and now pressing escape closes it. Okay, great. So that's basically it. Okay, let's at least draw something. So let's get back to the documentation, and let's find the proper segment. Yeah, here, modules shapes. So here we've got some functions that might interest us for drawing. So there is, for example, draw rectangle function. So we can take that, copy it, go to Sublime, and between begin drawing and end drawing, you can paste it, delete this, and let's start filling it in. So first of all, position X. So let's say it starts at 100. The 0 point of start here, 0, 0, is in the top left corner. So let's say 100. Position Y also 100. Width, let's say it would be 100. Let's say 400, and let's say 400. Color, let's say, though this is something you can also find in the documentation. If you scroll down, you will find some defines. So here are some colors defined as compound literals. Those are, I think, yeah, in C. So let's make it orange. Yeah, let's make it orange. Orange, yeah. And now let's compile and let's run. Yeah, and we've got a rectangle in the middle of our window. So yeah, that's it. So now we've got a basic project in which we can draw. Next time we will draw this rectangle using a shader, and then we will actually get to compiling some interesting and fun shaders. So yeah, just a bit more of this setup and preparation, and hopefully some actual fun. Yeah, so thank you for listening, and see you next time.